Let's give a nice AMA welcome to our friend Joe Bach.
Thanks, Sam. Well, first of all, I'd like to thank the Academy for inviting me here to participate in this year's AMA Expo. In addition, I'd especially like to thank the Academy of Model Aeronautics for all the support and encouragement we've received as a company and personally in preparation for this event, and throughout the last 20 years that I've been involved in model aviation. What I'd like to do this afternoon is give everyone a brief background on myself, and then give a brief overview of my company and some of the projects we've been involved with, and how airplanes and airplane models have played a major role in both. So I was born in Detroit, came out here to play football at University of Southern California. My parents encouraged me to pursue a degree in aerospace engineering while I was a member of the football team at USC. So USC had a world-class aerospace and mechanical engineering department, and I was fortunate enough to take advantage of that. The administration, my professors, and the coaching staff were especially supportive of my track emphasis with regard to my aerospace engineering degree. Then, as it turns out, my parents were right. Football doesn't last forever, and a few injuries later, I found myself at Northrop Aircraft Division as a junior engineer in the engine integration department of the F-20 Tiger Shark and later on the YF-23 program. Since then, I started a company in 1994 called Aero Telemetry, and it began as an outgrowth of model airplanes and my interest in electronics. We've grown to have products and services that are used on almost every single UAV project in the world, and on several mission-critical projects like the NASA Space Shuttle. Another project we worked on, it's fairly high profile, is one called the U.S. Army Excalibur Guided Munitions Program. We do the telemetry receivers. It's a transmitter embedded in the artillery round that after they fire it, they can track it as it's in flight. So this is a partial list of the people that we deal with, partially responsible for why I don't get to spend as much time as I'd like flying model airplanes, is taking care of our customer base. We also, post 9/11, got involved in unmanned air vehicle design and fabrication. Prior to that, I think if you actually asked someone in public about what a UAV was, they would say they didn't know. We picked up a lot of business post 9/11, and this is an example here. That's a all-aluminum unmanned air vehicle that was used to help a company design some payload requirements that they had. Around the 2003 period of time, I was approached to do the airplanes for the movie The Aviator. I'll start with the H-1 Racer. Again, due to time constraints, we had about 3 weeks to develop the H-1 Racer from scratch. There was no plans, there was no blueprints that we could go off of. We had a general idea of the shape, so you can see these photographs here. Basically what we had done is used a computer to form those foam blocks and then used a team of talented sculptors that shaped the fuselage and then put fiberglass over that and got it as close as they could get it to looking like an H-1. Some point after that, we actually tried a smaller engine in the plane thinking that it would be a lot lighter than it was. That didn't work out. We didn't have enough time to make a pattern, make a mold, pull apart. So we actually had to fly the pattern. And I think the fuselage was probably well over 200 pounds. The nature of the design of the H-1 airplane, you've got about a 6-to-1 difference between the CG and the tail of the plane, and an awfully wide chord. Our biggest concern after adding this new engine we have there and the landing gear was just trying to make sure the plane would balance. I think when we were all finished, we added 90 pounds of lead to the cowl, just the cowl, in addition to the engine that we had on there. These are some pictures from the first flight test and the second one. That's us at El Mirage Dry Lake Bed on the first flight. We had some issues with the propeller. We cut the propeller diameter down because of ground clearance issues. And the unscaled landing gear height was partially my call. I felt that it would be less of an imposition on the pilot to try and get that plane from the starting blocks up on the throttle without having it turned to the left. We didn't have a steerable tail wheel, all we had was a tail skid. So I didn't know if that was going to be a problem, so we cut the landing gear short. And that's a picture of our H1 pilot. That's Jason Soames. Jason flew the H1 Racer, not only at El Mirage on the first flight test, but at Santa Clarita as well. We flew it 2 more times there for the film cameras, and that worked out very well. Next plane is the XF-11, which is the airplane that Howard Hughes had crashed in. It's a twin-engine airplane. This was our flagship airplane. It was a daunting project, not without a lot of issues from the construction stage. These are guys here. That's Ian putting the fiberglass in the mold. That's me back there supervising the installation of the carbon fiber. We use 2 layers of 4-ounce glass and then carbon fiber strips and then aerosol that we'd sandwich in between the layers of fiberglass to make the skins for that. We had some issues with the wing, so we ended up having to weld that and make it into a one-piece wing. It made it a little difficult to transport it and move it around, and I think it took like 8 to 10 people to pick up that wing when we were finished with it as one piece and load it up. There's a picture of the engine installation, the cowl, and of course the hydraulic landing gear. Those landing gear were kind of tricky as well. Think about this, you've got the way the XF-11 works, you've got all the landing gear forward when down. Obviously when the plane retracts, you got 3 landing gear going back, an average distance of about 18 inches. So they probably weighed about 110 pounds. All 3 gear, we felt that was going to be an issue. When the gear retracted, the plane might go CG aft. There's a couple pictures from the flight. So the XF-11, our first flight was at San Bernardino Airport, or Norton Air Force Base. Most of the crew that was on the flight line that day had stayed up, well, at least 40 hours preparing for that. We were pretty exhausted, and the weather hadn't really cooperated for the film cameras. So it had that gray, overcast sky, and that didn't help the guys when they filmed it. So we still flew 2 times there. Now this is another thing. Think about this. So if you guys are modelers and you know how it is to go on a first flight test, you'd prefer not to have 400 people watching you, no pressure. Just go out and test your plane for the first time. And by the way, make sure it works. Plane has to fly perfect. There was a lot of pressure on us for that plane to work that day. About 3 or 4 months later, the film company decided they needed some additional shots, and the airport of choice at that point was Catalina Island. They've got a wonderful airport there. They call it the airport in the sky. We went out there, they did some shots with a helicopter that worked out just perfect. Spruce Goose. It's the 3rd plane in our primary models that we developed for the Aviator. This plane actually posed an interesting problem. Think about this. So the H1 Racer, we flew a big 360cc gear-reduced 2-stroke with a variable pitch propeller. On the XF-11, we used counter-rotating propellers and twin opposed 2-strokes. But it's a twin, so you've got issues with a twin airplane versus a single. So here now we're in multi-engine seaplane. And the primary concern of the film people, of course, is scale detail. There's 2 criteria here. We had to keep the engines inside the nacelle, and we had to be able to start it somehow, and the plane's in the water, Long Beach Harbor. So I met a fellow by the name of Don Holfeld and another fellow named George Peters. And they set up they brought these little motors to me that I could put in my hand and said, here's the motors you need to use to pick up the Spruce Goose, maybe 200-300 pounds. But I said, okay, we'll give it a try. And we did the same thing. We counter-rotated the propellers, starboard and port, as is the case always. The first flight test, oops. Uh-oh. This is a Windows computer. Didn't like that? Okay. Well, there's Windows for you. I can keep talking about that a little bit. So on the Spruce Goose, when we took that out there, it was a big push to get it out in the harbor on a Sunday, and filming was on Monday. So we had a big rush to get the plane out there, and I remember talking with Bill Hempel again on the way. They put us on a flat barge and took us out to a spot in the Long Beach Harbor where we could actually fly the plane. And again, it was a little historic because you're in roughly approximate location of where Howard Hughes took off that plane. An event like that has never taken place before or since. I was under the impression that the port of Long Beach was shut down. while we were in the air doing this. So there was, again, a lot of pressure on us to make sure the plane flew. We hadn't water tested it. We had no way to do that. So we weren't sure if it was going to float or sink. Plus we had, I think, about 160 nickel metal hydride batteries on board, which don't particularly enjoy being around salt water. And you've got electric motors inside these nacelles. So, you're hoping that salt water's not going through them. Anyway, on the barge out there, I remember talking with Bill, and I said, that's perfect. I asked him, I said, what do you think? And Bill's a normally very calm, cool pilot. He's a military pilot and very professional. So he just looked at me and said, he shook his head and he said, I don't think we're going to make it. So we thought, well, the worst case scenario is we could, tow the plane up with a Zodiac boat and then get that flight, the shot that, Howard Hughes had where he just flew the plane in ground effect. I figured we could do that. At least they had a good airfoil. I'll skip to the next slide here to show you that. Yeah, this is us on the first flight test. Any case, Billy just blipped the throttle and immediately you could hear the water go right through the propellers into the engine nacelles. Everybody at one time said, go, throttle it. And he hit a couple of bumps on the way out of there at full power, and to our complete shock, that plane came out of the water at about a 45-degree angle, like it was shot out of a cannon. So that's a big testament to electric motors. But it was obviously very exciting. The plane flew great. I think at some point, Bill just pulled back to half throttle and allowed the plane to cruise around and landed the plane perfect. So that really worked out good. It's just a 1-minute clip of our airplanes as they were actually used in camera for the film. Post-Aviator, we developed a little bit of capability with hydraulic landing gear. Fortunately for us, it actually led into some other business. Probably the highest profile project we've been on since is the X-48 for Boeing. We designed the nose wheel landing gear system for those guys. A lot of that was based off of the experience we had on Aviator, building the hydraulic landing gear from scratch for the H-1 and the XF-11. Those landing gear were critical to the success of those flights. If they had failed at any point, for any reason, in some position other than up or down completely, we'd have lost the planes. I mean, as you know, you bring an airplane in with the gear looking like that, it's going to cartwheel and make a mess. Our hydraulics engineer, Butch Fleck, he did an amazing job getting those things done and getting them operating properly. There's our X-48 work. Again, we designed the nose wheel landing gear for that. It involved a lot of data analysis and testing. I guess we could run a quick video on that if you'd like, and it's show you that. Yeah, so what we've done here is use these nitrogen-filled struts that provide rebound and damping, and then we've designed, manufactured, and assembled this This retract system runs off our own these actuators that we built, and a 24 volt like a military hydraulic pump, and it runs off an electromagnetic servo and pick that thing up. At the time, the XF-11 landing gear we built represented the most sophisticated, retractable landing gear ever built for a scale model airplane. This is a CAD drawing of the upper strut assembly for the main gear that we've fabricated. It's got the lock links on it. This is our nose gear assembly made out of steel. But there's your nitrogen-filled cylinder up here that gets pressurized before we take off. So what we have here is the H-1 landing gear that we've meticulously scaled down from the original drawings. We tried to stay as true as we could to the original design. There's a lot of design work, actually trying to get all the angles and pivot points and attach points and actuation methods correct. Thank you. And then I thought I'd touch on this real quick. At some point along the way, I got so busy with business. I'm a full-scale pilot, and I had aspirations of flying P-51s like Brad Lang. The closest I could get to that is engines, big ones. So we started restoring old radial engines that had some historical significance to them. And this one here is a 3350. This is the one we brought to the show today. It has quite a history, actually. It belonged on a Howard Hughes TWA Lockheed Constellation. It's one of about 4 in this particular dash number. It's unique insofar as it's fuel injected. It's got a twin supercharger that you shift at around 10,000 feet, and turbo compound, they call it. Turbo compound 3350. That's been a big project of ours, and we got that running after 60 years. You can see the video we have over on the display there that details a little bit about the troubles and tribulations of actually having to do that. Here's another one that got involved with St. Allison. This particular engine came out of a P-38, and it was the port engine that turns left. It was an interesting project in our first foray into the V-12 business. This engine here is the one that we're planning on using for the H-1, 50%. It's an interesting engine. Probably a lot of people never heard of it. This gentleman, Lawrence, actually worked for Orville Wright. Orville hired him for the Wright Corporation back in the 20s. Lawrence was the fellow that developed his Whirlwind engines. This particular engine, in the upper left-hand corner, that you can see the configuration of that, horizontally mounted 5-cylinder, and it drove a big generator that they used as an APU on the old China Clippers. When they went into the water and overseas, they had no way of starting those things if they didn't have enough battery power or anything like that, so they'd use these Lawrence engines. They're very reliable. It's a 4-stroke. Makes about 35 horsepower. It's direct drive. It's not gear reduced at all. But it spins a 60-inch propeller, which is 5 feet, and that's perfect for a half-scale airplane. So we're working on that. And actually, it wasn't intended to be in the H-1, but it's going to be a perfect fit, we think. So we worked on that. The last thing I'll talk about here is the project that we're working on right now for the AMA. The landing gear have posed to be the biggest design problem. So from photographs, basically, no drawings. It's duplicated in every possible way they can imagine. The rake, the pivot points, the actuation method is as close as we can get to the real thing. We've also spent some time working on the pattern. This time, since we have more than 3 weeks to actually work on the plane, we built a pattern. We took a little bit of artistic license, as you can tell on the back there, a little bit with some of the shape, to try and get the plane as close to perfect as we could get it. We put in the scale detail, the panel lines, the rivets, engine firewall cowl, and the actual cowl will be all aluminum. It's 3003 aluminum pieces, and we're hoping that comes out really nice. These are some pictures here. I suppose some of you have seen the video that we've got online on the H1 Racer as the intro, but in the interest of, for those of you who haven't seen it, I guess we'll just play it one more time. Other than that, I'll let them watch the video and say thanks. Thanks for having me here, and enjoy the show.